Hi, welcome to Ashok Kumar channel Physics. Today we are going to discuss about the rules of refraction. So previously in the first class of refraction of light, we have seen the introduction about refraction. What do you mean by the refraction? Just we will recall the previous class for 2 to 3 minutes so that we can continue this class. So what do you mean by the refraction? So refraction is nothing but a bending of light. Why do the light bends? Because it is traveling from one transparent medium to another transparent mediums. When it travels from one medium to another medium which are transparent, then light velocity is going to affect. As the light velocity changes, it has to choose another path which takes less time according to Fermat principle. So this is about the refraction what we said in the previous class, and there we said about the medium property. One medium to another medium it is going, then medium property is trying to change the velocity of light. That medium property which can affect the velocity of light, we said that one as a refractive index. And how the refractive index affect the velocity of light, how the velocity is going to increase, how many times velocity is going to increase, or how many times velocity is going to decrease. So we will say by comparison of refractive index. So if you compare the refractive index of medium with vacuum, then that is said to be absolute refractive index. If you compare the refractive index of one medium with the refractive index of another medium, then we will say that relative refractive index. Always the comparison is to get the velocity, how much velocity is going to decrease or how much velocity is going to increase. That's why we will compare the refractive indexes of two medium when light is traveling from one medium to another medium. Okay, so now the rules, how the light is going to bend. So well, the incident ray is going to bend from if it is moving from one medium to another medium. Suppose if this is medium 1, this medium I am taking as a rarer medium. So rarer medium, which is said to be the rarer medium, in which medium velocity of light is more, that medium is said to be rarer medium. So take that one as a refractive index mu1. That medium is having a refractive index mu1, and there is another transparent medium which is said to be the denser medium having the refractive index mu2. Okay. Suppose if a light is traveling, light can travel from denser to rarer, or it can travel from rarer to denser. So if there are transparent mediums, light can move from one medium to another medium. It can travel in either direction. Suppose if I am taking light is traveling from rarer to denser at an angle, not in the direction of the normal. So at an angle with normal, then this is the original direction. If there is no denser medium, it has to continue its original path like this. That is the original path of the incident rays. As there is a medium change, it is bending from the original direction. So how it bends? It either bends in this direction or either bends in this direction. When it is traveling from rarer to denser, it is going to bend towards the normal. Where is the normal? At the point of incidence, if you draw a perpendicular to the interface. So if you draw a perpendicular to the interface, this is said to be the normal. So and this is the original direction. From the original direction, when light ray travels from rarer to denser, it is going to bend towards the normal like this. From the original direction, it is going to bend towards the normal. Now this is the bending ray, which is said to be the refracted ray. That is said to be the refracted ray. And angle between this incident ray and normal, this is said to be the normal. Take this one as n dash. This is the incident ray. Angle between incident ray and normal, this is said to be the angle of incidence. And angle between, this is the bending ray. Bending ray, we will call that one as refracted ray. Refraction is nothing but bending. So as it is bending from the original direction, that is said to be the refracted ray. Angle between the refracted ray and normal, this is said to be angle of refraction. As we will see, angle of incidence is greater than angle of refraction because it is bending like this towards the normal. So angle of refraction is going to decrease when light is traveling from rarer to denser. So we will see the rules when light is traveling from rarer to denser. First, what happens to the velocity when light is traveling from rarer to denser? So, first, before going to velocity, how it is going to bend? So, first point, as the light is moving from rarer to denser, it bends towards the normal from the original direction. So, this is the original direction. From the original direction, it is going to bend towards the normal. Bends towards normal. From where? From original direction. Bends towards normal from original ray. And next, what happens to the velocity when the light is traveling from rarer to denser? In the rarer, it is having more velocity. In the denser, light is having less velocity. That means light velocity changes from more to less. That means light velocity is going to decrease. So when the light is traveling from rarer to denser, velocity of light, that is magnitude of velocity of light, is going to decrease, because in the denser medium light is having less velocity. So more velocity to less velocity. That means the velocity of light decreases when light travels from rarer to denser. And the next one, how these are related? Angle of incidence is greater or angle of refraction is greater? Angle of, if you see, angle of incidence is greater because this ray is coming like this. So that means refracting angle is decreasing. So angle of incidence is greater here than angle of refraction. And here also there is an angle which is said to be deviation. Light ray is deviated from the original direction like this. This is said to be deviation angle. So if you denote the deviation angle with a delta, what is this deviation angle? This deviation angle we will get from, you can subtract the total angle from this angle. So then you will get deviation angle. So this is the incident ray. This is the incident ray. Angle between, this is also incident ray. So angle between incident ray and normal, this is angle of incidence. So this total angle is angle of incidence. I need only this angle. So from the total angle of incidence, if you subtract angle of refraction, then you will get deviation angle. So then how much you are going to get the deviation angle? Deviation angle is this angle. From the total angle of incidence, if you subtract a refracting angle, then you will get a deviation angle. So which is I minus R. Sir, can you write R minus I? No, you cannot write R minus I because angle must be always positive. Positive, as it is positive, you need to subtract from the higher value minus lower value. Angle of incidence is greater here. So higher value minus lower value. This is deviation. So deviation angle is I minus R. So these are the rules when light is traveling from rarer to denser. So now, if a light ray is traveling from denser to rarer, these are the rules. You can take the rules and you can expect the questions. Suppose there is a 1 mark question. What happens to the light ray when it is traveling from rarer to denser? So you can write it is going to bend towards the normal. Or you may get the question like this. When the light ray is going to bend towards the normal. When light ray bends towards the normal. So you need to write as it is moving from rarer to denser, then it is going to bend towards the normal. So and if you are given like this, so a light ray is passing from one medium to another medium and we can observe that angle of incidence is greater than angle of refraction. Then can you say from which medium to which medium it is passing? As angle of incidence is greater than, here angle of incidence must be greater than angle of refraction. See, as angle of incidence is greater than refracting angle, then we can say light is traveling from rarer to denser. Here angle of incidence is more compared to angle of refraction. Okay. So now these are the rules when light is traveling from rarer to denser, and you can expect the questions based on these points. What happens to the velocity of light when it is traveling from rarer to denser? You can say velocity of light is going to decrease when it is traveling from rarer to denser. And next, you can take this as snapshot when light travels from rarer to denser. Okay. And next, if a light travels from denser to rarer, we are forming the rules. Either it can travel from rarer to denser or it can travel from denser to rarer, because both are the transparent mediums. So if a light ray is traveling from denser to rarer, suppose there is an interface which is dividing the rarer medium. So take the same position of the rarer medium. Here is the rarer medium having refractive index mu1, and here is a denser medium having a refractive index mu2. Now if object is in the denser medium, then light travels from the object. So then if a light travels in this direction, if object is here, if object is in the rarer medium, then light travels from the rarer medium. If object is in the denser medium, then light travels from the denser to rarer. So now as the object is in the denser medium, then light travels from denser to rarer. So as we have observed, this is the original direction. If there is no rarer medium, as there is a rarer medium property changes, then it can bend either towards the normal or away from the normal. So we have observed that when light travels from denser to rarer, it is going to bend away from the normal. So you need to draw the normal. Normal is nothing but a perpendicular drawn at the point of incidence. This is the normal. This is the original direction. From the original direction, it is going to bend away from the normal. It is going to bend like this, away from the normal. Now this is the bending ray, that is said to be the refracted ray. Now this is the refracted ray. So then angle between the refracted ray and normal, this is said to be angle of incidence, and this is angle of refraction, and this is angle of incidence. Now if you see, angle of refraction is greater than angle of incidence, as it is bending away from the normal, and this is said to be the how it bends. It is deviating from the original direction like this, that is said to be the deviation angle. Now what happens, denser to rarer, as the light is moving from denser to rarer, we can say it is bending away from the normal. So it bends away from what? Away from normal, from the original direction. It bends away from the normal, from the original direction. And next, what happens to the velocity of light when it travels from denser to rarer? In the denser, velocity of light is less, and in the rarer, velocity of light is more. That means it is having the velocity from less to more. That means it has a velocity is increasing. Less to more means velocity increases when it travels from denser to rarer. And the next one, which is greater here? Angle of refraction is greater than angle of incidence. Angle of refraction is greater angle of incidence. That means angle of incidence is less than angle of refraction. And next, how do you get the deviation angle? Deviation angle here is, this is the incident ray. Angle between the incident ray and normal, this is said to be angle of incidence. And this total angle is angle of refraction. From the total angle, if you subtract angle of incidence, then you will get deviation angle. So then deviation angle is R minus I. So previously we will get when light travels from rarer to denser, deviation angle is I minus R. Now if it is traveling from denser to rarer, then you will get the deviation angle R minus I, because in order to get the positive value, here R is greater value. R is having great value than the angle of incidence. So these are the rules how the light behaves when it travels from denser to rarer. Okay. So you can take a snapshot and you can expect the questions from these points. As the velocity of light is increasing, if it is traveling from one transparent medium to another transparent mediums, can you say from which medium it is traveling? As the velocity of light increasing, we can say that light is traveling from denser to rarer. And we have observed that when light is traveling from one medium to another medium, we have observed that angle of incidence is less than angle of refraction. So can you say from which medium to which medium it is traveling? We can say as the angle of incidence is less than angle of refraction, we can say that it is moving from denser to rarer. So you can expect the questions like this from these points. 1 mark questions. And next, what happens if a light ray is sending in the direction of normal? So we are sending at an angle to the normal, rarer to denser or denser to rarer. Suppose if you send in the direction of the normal, these are the rules, rarer to denser and denser to rarer. And when light is sending at an angle, suppose if we are sending not at an angle, in the direction of the normal. So this is the rarer medium. If you assume rarer medium is having refractive index mu1, and if you take this one as denser medium which is having refractive index mu2. So if a light is sending in the direction of the normal, normal is nothing but at the point of incidence, if you draw a perpendicular, that is the normal. Now this is the normal. Suppose if you send light ray from rarer to denser or denser to rarer, so in the direction of the normal, if a light ray is sending in the direction of the normal, this is said to be in the direction of the normal, then what happens? How it is going to deviate? It does not deviate, it continues its original path, but velocity magnitude is going to change, but it continues the same direction. There is no deviation happens from the original direction. So refraction does not happen. Refraction is nothing but a bending of light. So here there is no bend from the original direction. It continues the original direction. There is no bending happens. So then you may expect the questions, what is the condition for the refraction not to be happened? So the condition is you need to send a light ray in the direction of the normal, either from rarer to denser or denser to rarer. So this is the condition, refraction not to be happened. Bending is not to be happened. In this case, the deviation angle is 0. So because the deviation angle, you can take r minus I or I minus r. If you take I minus r here, angle of incidence is 0. Angle between the incident ray and normal, that is the incident ray, that is the normal. Angle between incident ray and normal is 0. And refracting angle, this is the refracting ray. Angle between the refracted and normal is also 0. 0 minus 0, you will get angle of deviation is 0. There is no deviation happens from the original direction. Okay. These are the rules. And there is a law, refraction laws. Rules we have completed. If it is traveling from rarer to denser, and if it is traveling from denser to rarer, and if you send a light ray in the direction of the normal, how the light behaves. There is another rule is there, law, not the rule. Now it is the reflection laws, which is the Snell's law. When refraction happens either at the plane surface or at the curved surface, if a refraction happens, then you can apply the Snell's law. Snell's law is applied for only transparent mediums. Suppose if there is a medium, if there is an interface which is dividing the light, so if a light is traveling in this direction at an angle, now this is the point of incidence. At the point of incidence, if you draw the normal, this is the angle of incidence. Now from the original direction, this must be the original direction. From the original direction, as it is moving from rarer to denser, if you assume, then it is going to bend towards the normal. It is bending towards the normal from the original direction. Suppose if you increase the angle of incidence, if I increase the angle of incidence, same medium, so here is the rarer medium and here is the denser medium. So if you make the mediums constant, and as we are increasing the angle of incidence, now this is the angle of incidence, this is the angle of incidence. So this is the original direction. From the original direction, it is going to bend towards the normal like this. Now this is the refracted ray. Now this is angle of refraction. So as the angle of, this is the angle of refraction here. As the angle of incidence increases, this is the angle of incidence here, this is the angle of incidence here. So this is the angle of refraction here, here is the angle of refraction. As the angle of incidence is increased from here to here, angle of refraction also increases. If you see the diagrams, suppose if you send another angle, if you further increase the angle of incidence, if I further increase the angle of incidence, now this is the normal, now this is the angle of incidence, I have increased the angle of incidence. So it is traveling from there to denser. This must be the original direction. From the original direction, it is going to bend towards the normal. It is bending towards the normal. This is the refracted, and now this is the angle of refraction. So as the angle of incidence increases, angle of refraction also increases. But the ratio of sine of angle of incidence, here if you take a sine of angle of incidence to sine of angle of refraction. So if you take this one as I1, this one as R1, this is I2, this is R2, this is I3, this is R3. So here sine I1 by sine R1, if you take here. And here also, if you take a sine I2 by sine R2. Ratio of sine of angle of incidence to the sine of angle of refraction. Here if you take this is the sine of I3 by sine of R3. But this ratio is always a constant. Whatever may be the angle of incidence and whatever may be the angle of refraction. So, but the ratio of sine of angle of incidence to the sine of angle of refraction is constant. So, you will get whatever the ratio you will get here, you will get the same value here. So, whatever the ratio you will get the same ratio here. Here also you will get the same ratio. Here also you will get a constant value. So, that constant value is equals to, what is that constant value? That constant value is equals to refractive index of the second medium by refractive index of the first medium. That constant is always equals to refractive index of second medium. Here the second medium is nothing but where the refraction happens. Where is the refracted ray? That is said to be the second medium. And where is the, in which medium the incident ray is, that is said to be the first medium. So then this is always a refractive index of the second medium by refractive index of the first medium. So second medium is nothing but in which medium there is a refracted ray, that is said to be second medium. Obviously, opposite to that one, in which medium there is an incident ray, that is said to be the first medium. So here also you will get the same one. So here also same mediums are here, but angle of incidence and angle of refraction we are changing. Here also you will get the same ratio, which is mu2 by mu1 as refractive index of second medium by refractive index of first medium. Here also, even though you are increasing angle of incidence and angle of refraction, but you will get the same ratio. By keeping the mediums constant, we are increasing the angles of incidences so that we will get the increased angle of refraction, but the ratio of sine of angle of incidence to the sine of angle of refraction is constant. That constant is angle always refractive index of second medium by refractive index of first medium. So here I am rubbing them. So now I am generalizing the formula, Snell's law, which is always this one, as you can write the generalized formula. This is always refractive index of which medium here? Refractive index of second medium. Refractive index of second medium by refractive index of first medium. First medium is nothing but where is the object, that is said to be the first medium. Second medium is nothing but where is the refracted ray, that is said to be the second medium. Okay. Sin I by sin R is always equals to mu2 by mu1. So this is the Snell's law. According to Snell's law, as we have seen one case where the refraction does not happens. So what is the condition? Refraction not to be happened. So we have seen that if you send a light ray in the direction of the normal, then refraction does not takes place. Here another condition is there, refraction not to be happen even though if we are sending at an angle. So that is if they are having, suppose if you take sin I by sin R, if the mediums, there are different mediums are there, light is traveling from one medium to another medium, which are the different mediums, but if they are having same refractive index, even though they are different, but if they are having same refractive index, if mu2 is equals to mu1, then they are going to get cancelled, then you will get 1. Then you will get sin I is equals to sin R. Sin I is equals to sin R means angle of incidence is equals to angle of refraction. That means there is no deviation happens. Suppose if you send a light ray at an angle, this is medium 1 and this is a medium 2. If they are having same refractive index, so this is having a refractive index mu, this is having a refractive index mu. If both are having same refractive index, then if you send a light ray at an angle, even though if you are not sending in the direction of the normal, even though you are sending at an angle, then it does not deviate from the original direction, it continues its original path. So when it continues the original path, when refraction does not takes place, one condition is that one, when you are incidenting the light ray in the direction of the normal, then refraction not takes place. So this is another case. So even though if you are sending at an angle, if the mediums which are different, but if they are having same refractive index, then also deviation does not happen, it continues its original path. These two are the conditions where refraction does not happen according to Snell's law. There. This is the Snell's law. Snell's law is very important, and this formula is very important. Sin I by sin R is always equals to refractive index of the second medium by refractive index of the first medium. So this is the class for today, and in the next class we are going to see how the images are going to form when a light ray is traveling from rarer to denser, and how do you get the images when light ray is traveling from denser to rarer. So because always we are getting the images either because of the reflected rays or because of the refracted rays. As the light ray is refracted towards the normal, how do you get the image? As the light ray is refracted away from the normal, how do you get the images? So how do you apply them for real life conditions? Okay, this is what we are going to see in the next class. Thank you for the today's class. Hope you have understood. Bye.